Good morning. My name is Marco del Moral, and I will be presenting our work Intelligent Mobile Application to determine the existence of medicines associated with COVID-19 in a social network of medical dispensaries in a smart city. On behalf of our team composed of Dr. Alberto Aguilar and Dr. Alberto Ochoa. The pandemic has shown the passivity of healthcare information systems and the necessity of an holistic approach that can provide them with the sufficient dynamism to cope with nationwide scale phenomena, especially in developing countries such as Mexico, which is in the middle of transitioning from classical pen and paper national health management to a digitalized one. As much as half of Mexican population doesn't have access to telecommunications network. Industry 4.0 solutions such as wearables are not easy implemented. This is why our proposal focuses in developing a tool to help medical staff to take better decisions using an holistic approach. Our proposal focuses in the capital of León in the state of Guanajuato, a high-density territory susceptible to epidemics. The objectives are to develop a hybrid intelligent system supported by modern technologies such as mobile computing and data warehouses, capable of finding solutions to problems related to humanitarian logistics. Regarding medical dispensaries, its geospatial distribution and inventory levels to cope with the effects of current pandemic, providing insight and pattern recognition to coordinate government response with the purpose of finding contagion hotspots and coordinate different agents to provide a better response and in turn save lives. Mexico is one of the countries most affected by the current pandemic, so it is imperative to generate joint efforts to support the vulnerable population and reduce the suffering that the disease causes. Data warehouses are of utmost importance in this type of problem since it must consider the support responses to find medicines. The data warehouses can be perceived as a previous concept to data mining. A data warehouse is comprised of operational data and is designed to facilitate decision making. It integrates and makes consistent the data extracted from operational databases. Therefore, the data warehouse is structured data for the execution and generation of reports related to the activity of our organization. Data mining is within the set of knowledge discovery techniques and can be defined as non-trivial extraction of implicit, previously unknown, and potentially useful information from data. We can make an analogy describing the knowledge discovery in databases. Data can be seen as a commodity, such as iron, that has to be refined to be useful. Data is extracted from a database, preprocessed and filled within a warehouse. In there, it is refined to find relevant information, and then, with data mining, we can convert this information and transport to a computed algorithm and find patterns. In turn, these algorithms output knowledge that can be used to make compelling decisions. The data mining process can be abstracted as a bidirectional concept, starting with a graphical user interface for the human user and implementing pattern recognition algorithms and data mining supported by a knowledge repository. Data mining is implemented within a computational architecture, simplified in this diagram inside the database server block. Right now, the most common implementation of this architecture is via cloud providers. Finally, the whole process is built on top of the databases and warehouses. These databases can range from medical data to geospatial and demographic data. In fact, the combination of different data sources improves the efficacy of systems, especially while modeling complex systems such as humanitarian logistics. Meta heuristics are a family of high-level algorithms capable of finding or approximate solutions in complex mathematical spaces. They are used to find sufficiently good solutions to optimization problems. Humanitarian logistic problems, such as ambulance routing, belong to the most common difficult class of computational problems, the so-called NP-hard problems. The average computing time for traditional algorithms optimizing these humanitarian logistic problems can explode from seconds to millions of years. Meta-heuristics can provide feasible and approximate solutions within a usable time frame. A cultural algorithm, or CA, is a class of evolutionary algorithm that can be seen as an improvement of the classical genetic algorithm. CAs have three main components: a population space, a belief space, and a protocol that describes how knowledge is exchanged between the first two components. The knowledge produced in the population that the space at the microevolutionary level is accepted or passed onto the belief space and used selectively to adjust the knowledge structures. CAs use 5 types of basic knowledge to solve the problem rather than just transmit a value. Sources of knowledge include normative knowledge, ranges of acceptable behavior, circumstantial knowledge, examples or memories of successful and failed solutions, among others, domain knowledge, knowledge of domains, their relationships and their interactions, historical knowledge, temporal patterns or behavior, and topographic knowledge, spatial patterns of behavior. The prototype is an intelligent hybrid system developed with the Java programming language that combines data mining techniques with CAs. It started with creating a network that combined colonies locations in the city of León and the locations where each of them was connected, and the distance between those nodes within the map. Once the network was finished, we continued with the construction of the data warehouse, which was integrated by the following fields: area, colony, year, month, day, hour, and type of medical emergency. First, we compiled several databases to be preprocessed and fed to the data warehouse. The databases used consist of the geospatial data of the city of León, demographic data such as population density, and healthcare-related data such as inventory levels of dispensaries. As there are several dispensaries within a particular city, neighborhood, or colony, we use an unsupervised machine learning algorithm to cluster the dispensaries and find the center of those clusters. These will be the nodes of the networks fed to the cultural algorithm. This element processes the information using the other databases to generate a population whose agents will find the optimal route. Our first prototype iteration can classify, cluster, map, and generate tours. It was necessary to the creation and implementation of algorithms capable of finding information in n dimensions, such as k-means, which groups a set of data without having predefined classes, based on the similarity of values of the attributes, performed in an unsupervised way. The present research has demonstrated that it is not only feasible to apply data mining to dispensary information in the city of León, but also its high added value for the analysis and generation of new knowledge that, together with the cultural algorithms responsible for the creation of distribution routes, bases the new knowledge acquired, providing support to be carried out based on historical facts, not only the randomness as occurs in almost all healthcare organizations. With this, we intend to resupply important areas, providing a new paradigm for a substantial improvement in the logistics of public healthcare. In our future research, it is very important to consider an intelligent dashboard associated with humanitarian logistics on a mobile device. Future work will focus on implementations of these findings in a real software system capable of solving dispensary distribution seamlessly using concepts drawn from Industry 4.0. This software will be composed of a web app capable of running in most computers and cell phones, maximizing its usability. Also, it has to interface with several inventory software and point-of-sale hardware. Compatibility is an ongoing problem and it has to be solved. Inclusion of modern techniques such as deep learning is also on the scope of future research. Thank you very much.